To graph the solution set of this system of linear inequalities, we graph each inequality separately and then look for the overlap of the two solution regions. That'll be the solution of the system. Okay, so to graph the first region, the two-step process is to first graph the line 2x plus y equals 2. And we need 2 points on the line in order to graph it. And if x is 0, then y is 2, because y equals 2. X is 0, the first term vanishes. And if y is 0, then 2 times 1 is 2. Those are 2 points on the line, so we can certainly graph that line. There's the y-intercept, 0, 2, and the x-intercept is at 1, 0. So our first line looks like this. It's a solid line because it's or equal to here. And now for the second step, to finish graphing the first of these two linear inequalities, we need to decide which side of the line to shade. So we can ask, is the origin shaded? Here's the origin. And to answer the question, is it shaded, is it on the shady side of this line? We take the original inequality, 2x plus y, less than or equal to 2, and see if it's true. And we plug in x equals 0 and y equals 0 into the inequality. Indeed, the left side is 0, and 0 is less than or equal to 2. So the answer to the question here is the origin shaded? Yes, it is shaded. Okay, so the shady side of this first line is the side with the origin on it, this side. So here's the first of the solution regions. So that's the solution set of the first of these two linear inequalities. Now we have to do the same process for the second of these linear inequalities and look for where the two regions overlap. So now we've got to graph the line x minus 2y equals 4. Now we're looking at the second of the two inequalities. Okay, so to graph this line, once again we need 2 points that are on the line. And if x is 0, we'll have the y-intercept. If x is 0, then negative 2 times negative 2 is positive 4, so y must equal negative 2. Well, if y is equal to 0, then x equals 4. So those are 2 points on the graph. And we can graph that line. 0, negative 2, the y-intercept is at negative 2. And the x-intercept is at 4. So 1, 2, 3, 4 is about here, the x-intercept of this line. So our second line looks like this. And we need to find out now which side of that line do we shade. So once again we can ask, is the origin on the shady side of this last line we just graphed? In order to satisfy the second of these two linear inequalities. So we substituted into the second linear inequality x minus 2y greater than or equal to 4. Now this time when you substitute a 0 for x and a 0 for y, the left side's 0 and the right side is 4. So That's false. No, 0 is not bigger than 4. So that's the answer to the question, is the origin shaded? The answer is no, it is not. Okay, if the origin isn't shaded, it must be the opposite side of that origin side of the line that gets shaded, so it's this downside here. Now, so that's the solution to the second linear inequality. The solution region we're looking for now is the overlap, the intersection of both of those solution regions. So it's everything including this line, everything including this line down, and the entire region in between here, where both of the solution sets were graphed from each of the two linear inequalities that made up this system. So this is the solution region, this infinite wedge-shaped region, to our system of linear inequalities.